In this video, we're going to see how you can use Excel's present value function to easily work out the present value of money received in the future. We're going to start off with a few simple examples so you can see how the function works before we move on to more complicated examples for both even and uneven cash flows. And if you'd like a copy of the Excel template we use in this video, or if you'd like to learn more about present value, check out the links in the description below. Okay, let's go to Excel now and get started. Okay, so we're over here in Excel and we're on the simple example worksheet. And what we're going to do first is answer the question, what is $1,000 in 1, 2, and 3 years' time at a 5% discount rate worth today? So I've got the variables set up here where we've got the years 1, 2, and 3 as the periods. And we've got the $1,000 for each year as the future value of our amount. And then we've got our discount rate of 5%. So we're going to start by doing the calculation manually, starting with year 1, down on the line where it says present value manually calculated. So we'll do it as a formula first, and that will give us some insight as to how the Excel function works. So the way to do your formula is to start off with the equal sign, and then grab the $1,000 up here at cell D5, and then put in a divide sign, open the brackets, and then it's 1 plus the discount rate of 5%, which is at D6. Then close the brackets, and then you need to add the symbol for the power of, which you get by pressing Shift F6. And to finish the formula, we'll grab the period, which is at D4, so that's the number 1 there, and press enter. Okay, so there's the formula there, and the answer we get is $952. So what this is telling us is that if we receive $1,000 in 1 year's time, it's only worth $952 in today's money, assuming a discount rate of 5%. And that's a perfect example of how the value of money decreases over time due to things like inflation. Put another way, if you received $1,000 today, it would be worth $1,000 and you could buy $1,000 worth of goods and services with it. But if you receive $1,000 in 1 year's time, you could only buy $952 worth of the same goods and services, assuming that the rate of inflation was 5%. Okay, so now that you know how to do the calculation manually, let's do the calculation for year 2. So if I just drag the formula across like that, and then we'll go into it and have a look, you can see that this formula is grabbing the $1,000 and it's dividing it by 1 plus 5%, and it's doing it to the power of 2, which is in cell E4. And that's because there are 2 periods now instead of just 1. So you can see that all of the variables for year 2 are just the same as the variables for year 1, except for the number of periods. And if we come out of the formula, we can see that the present value of that $1,000 is only $907. So it's less than the present value when there was just 1 year for the number of periods. So what this is telling us is that with everything else being equal, the more time periods that go by, the less valuable your $1,000 is in today's money. In other words, if you receive $1,000 in 2 years' time, you'll only be able to buy $907 worth of the same goods and services that you could buy today for $1,000. Okay, so let's drag that across to year 3 and we'll see that even more. So if we just have a look, we can see that that's referencing all the right cells. And now it's telling us that in 3 years' time, if we receive $1,000, it's really only worth $864 in today's money. Okay, so that's how you can calculate present value manually. Let's have a look now at how Excel can do it automatically with its present value function. So to get started, just type in the equal sign and then PV, open the brackets, and then we just need to grab all the variables. So the first one you can see here is the rate, which is 5%, and press comma. Then we've got the number of periods, which is 1, and press comma. Then we've got the payment variable. Now, the payment variable is used if there's more than one amount to evaluate, and an example of that would be an annuity, which is something we're going to look at in a minute. So we're not going to use the payment variable here, so we can just press comma again, and then we can grab the future value, which is the $1,000. So you use the future value variable when there's just one amount to evaluate, which is exactly what we're doing in this example. Okay, then you can press comma to get to the final variable, and this one is for whether the payment is timed at the end of the period or the beginning of the period. So because we've only got one amount here, if we choose either one, we're going to end up with the same result. And just to let you know, if you don't choose any of them, Excel defaults to end of the period, and that's exactly what we're going to choose here anyway. So we'll press 0 and close the brackets. Okay, so now we end up with minus $952, and the reason it comes up as a minus is that the present value function assumes that the $1,000 is an investment that you're making. So it's a cash outflow, and in finance, cash outflows are represented as a minus. So if you want to, you can leave your answer like that, but if you want it to show as a positive number, all you need to do is right there between the equal sign and the PV is just put in a minus and click on enter. And now it will show as a positive number. And you can see that we got the exact same answer that we got when we calculated it manually. Okay, so let's drag that across to the next one. And you can see once again, we get the same answer of $907. And then we'll drag it across to year 3. And once again, we get the same answer of $864 as we got when we manually calculated it. Okay, so our present value function is working perfectly. All right, there's one more thing I want to show you before we go to the next worksheet. So I'll just copy all that and then just paste it over here out of the way a little bit. And what I want to show you is what happens if we have a higher discount rate. So we're going to compare column H with column F and see what happens if I change the 5% to 10%. Okay, so what we can see is that the higher discount rate has resulted in a lower present value. So what this is telling us is that with the other variables being equal, so the period and the future value are the same in both examples, when you have a higher discount rate, you end up with a lower present value. Okay, so let's move on to the next tab now, which is investment 1. And over here, what we're going to do is answer the question, what is a cash flow of $1,000 per year for 5 years at a 5% discount rate worth today? Okay, so I've got it set up down here in much the same way as the last worksheet, except here we actually have a cash flow, or in other words, multiple payments for 5 years. So the total of the cash flows is $5,000, but what we're going to do is work out the present value of the cash flow. Okay, so once again, we'll come down and we'll do it manually first. So we'll just type in equals and get the $1,000 there at D5, divided by, open brackets, 1 plus 5%, and then we'll close the brackets and do that to the power of the number of years there, which is 1, and we get $952. And you can see that we're summing it over here in the total column. Okay, so what we'll do is we'll just drag that across, and that should work out the present value of each of those cash flows individually. So that's the individual cash flows, and these are the present values of the cash flows along here. And then this is the total present value of that $5,000 cash flow. Okay, so we can just double check our formulas by clicking on this final formula here, and we can see that it's looking up the right variables. So we can safely assume that the formulas are working all the way along. So now what we'll do is we'll use our present value Excel function to work it out in a much easier way. So we don't need to do it year by year. We can just come over to the total column and just type in equals, and then minus, and then PV for present value, and open the brackets. Now we've got to grab our variables. So the first one is the rate, which I'll just grab from year 5 here, and then I'll press comma. Then we've got the number of periods, which is 5. So I'll just grab that one there and press comma. The next thing we've got is the payment. So we're going to use that variable this time because this is a cash flow rather than just a one-off payment. So we'll just click on cell H5 to grab that $1,000 and then click on comma. And this time we're not using the future value variable, so we can just click on comma and go past it. And then finally we've got the type. So we can choose from end of period or beginning of period. So we're going to use the end of period here. And once again, just to let you know that Excel will default to end of period if you don't pick either of them. But you can pick beginning of period if you're doing this for the type of annuity that requires a payment at the beginning of the period. But just to let you know that you will get a slightly different answer if you choose beginning of period than if you choose end of period. So you've got to make sure you pick the right one. Okay, so I'll just type in 0 there to get end of period and then close the brackets, press enter, and there you have it. So we have $4,329 as the present value of the $5,000 cash flow. And you can see that with the present value function, we don't need to go and calculate every single year individually and then add them up. We can just put the function in once and Excel will do the work for us. Okay, so let's go to the next tab now. And what we're doing here is we're answering the question, what is a cash flow of $1,100 per year for 5 years at a 9% discount rate worth today? And the reason we're doing this, even though it's pretty similar to the last one, is that we just want to compare the answers to each other. So in the last one, we had payments of $1,000 per year at 5%, while this example has got a slightly higher amount each year of $1,100 and a higher discount rate of 9%. So I'm doing this to show you that you can use the present value function to quickly compare different scenarios like this to see which one has the highest present value and which one has the lowest. So let's just go in and do this quickly. So we know how to do our manual calculation. So I'll just type this in quickly. So we've got equals the value of the cash flow there, divided by, open the brackets, 1 plus the discount rate, close the brackets, and to the power of the number of periods. Okay, so that's the present value of that $1,100 at a discount rate of 9%. If we drag the formula across and then just check our last formula over here to make sure it's looking up the right variables, and it is. Okay, so the total present value that we get there is $4,279. So now we'll do it with the Excel function down here. So we'll just type in equals minus PV, open the brackets, we'll grab the rate and the number of periods and the regular payment amount. And there's no future value to fill in. And the type will be end of the period. Close the brackets to give us the present value of the 5 $1,100 payments over 5 years at a 9% discount rate of $4,279. And shortly I'll show you how that compares to the first investment. But before that, the last thing I want to do is just come over here to this tab, Investment 3, and I just want to show you how to do the present value calculation for an uneven cash flow. So in our last couple of examples, we had the same amount every single year, but in this one, as you can see here, I've got different amounts each year. So what you need to do for this is if we go in and do our manual calculation first, so we've got equals, we'll grab the future value there, divided by, open the brackets, 1 plus the discount rate, close the brackets, and to the power of the number of periods. Okay, so that's the present value of that first payment. So we'll drag it across, and then we'll check the last formula again. So it looks like all the formulas are working. Okay, and we've got a total of $4,403. So what I'm showing you here is that if you have uneven cash flows, you can't just put one present value function over here and get the result. You actually have to do each year as a separate calculation and then add them up. So it's a matter of going equals minus PV, open the brackets, get the rate, get the number of periods, and this time we're not going to use the payment variable because we don't have the same amounts each period. And instead, we've just got one payment to evaluate in this function. So we'll press comma, and then we'll use the future value variable, which is that amount there, and then comma. And then once again, we'll choose end of period, close the brackets, and we get $1,429, which is the same as when we did it manually. So we'll just drag that across and have a look at the last one to make sure it's looking up the right variables, and it is. Okay, so now we get the answer of $4,403. So that's the combined present value of those future cash flows. And once again, just to reiterate, what I'm showing you here is that to use the present value function for an uneven cash flow, you have to calculate each year individually and then add up the results. All right, so now we've done all our calculations. The last thing I want to show you is just this comparison tab. So over here, we're comparing all three of those investments. So we've got the total future value here of each of them. We've got the discount rates, and we've got the present value that we worked out down here. So with the first one, we had an even cash flow of $1,000 per year for 5 years and a discount rate of 5%. For the second one, we had an even cash flow of $1,100 per year and a discount rate of 9%. And for the third one, we had an uneven cash flow that added up to $5,000 and a discount rate of 5%. So you can see the answers down here, and it shows that investment 3 has the highest present value. So from this, you can see how the present value calculation in Excel is a good way of helping you compare different investment opportunities to see which one is worth the most in today's money. And that's particularly useful when you have things like different discount rates or if you have an uneven cash flow to evaluate. Okay, so that's how you can use the present value function in Excel in a number of different ways to easily get the present value of future cash flows and compare them to each other.